15. We stopped at 15. Right?
Yeah, but I made progress yesterday with my Wednesday class.
She's doing the YouTube thing.
Yeah.
She's doing the YouTube thing where she can do a little bit of every one of the problems with all
Yeah,
of us.
it'll be on YouTube though. I'll post it.
It's already recording. Do not go above 46. I don't know when I hit the thing.
In here.
Yeah, you can't write anything above that.
Okay. Okay. All right, so here we go. Number 46 says sketch the graph of y equals f of negative x. So that is telling you that for your function f of x and these choices, we're going to flip the x value to its opposite. So f of negative x means the graph flips left-right. It flips about the y-axis. Anything that was a positive x, we're changing to a negative x. So right now, the original graph, the f of x graph, the basic graph there is the x squared graph, the parabola. The shifting rule moves it back 7 and up 5. But if you have any doubt and you get nervous the day of the test, find one t-table value may be enough to narrow down your choice between A, B, C, D. So let's say I just want to plug in your favorite number for x. Maybe plug in 0, see what happens. And then punch that in on your calculator, see what the output is. So that's something you can quickly do just to check yourself and see 2/7 times 7 squared plus 5 would be 2/7 times 49 plus 5. The 7 cancels into that, so 14 and 5 is 19. So look for the graph that looks like it hits 0 and 19. That doesn't help a lot because it's such a big number, it's not fitting on the 10 by 10 grid you've got, but it does tell me it's not choice D. Choice D goes through 0 and 10, so that rules that out. But anyway, shop for another point. Maybe plug in a negative number, -5. If the first t-table value you try doesn't really give you a good output, just try something else. So that's 2/7 times 4 plus 5. So that's 8/7, almost 1. Just a little more than 1. 1 plus 5, so it's a little more than 6. So look at the graph that's back, has the point, back 5, and up 6. And there's only one that hits in that category. It's graph B.
Where did the -5 come from?
Just picking a number, random number. Yeah. For the t-table, just picking things that you feel like trying, plugging in for x. See if you get a number that fits on the graph. Sometimes you don't, like that 0 and 19, that was too big, so I just shop for another number. Just try.
Shouldn't x be 7?
What?
Shouldn't x be -7?
For this? Yeah, for the real vertex, what I'd really like for you to know is if you plug in -7, that gives you the actual vertex of it. That's a better point. So yes, but -5, 6 is a real point that's on the graph as well. Yeah, this is what I prefer that you know. I prefer you know that that is a -7 shift, that whatever's grouped with x, you do the opposite, so the vertex is moved back 7 and up 5. And then this affects how steep it is and everything, but that's a real critical point.
So to find the answer, we just need to take -7 and 5, right?
Yes, that's a good one to do, yes. You could tell the vertex is at -7, 5, but I'll tell you what, though, there's two answers that has -7, 5 on it. Still A and B. So you still need to narrow it down between those two. And what you could do is know that a fraction makes it wider. So it's the wider graph. So anyway, this t-table is just another strategy just to double check your work. If you're not absolutely positive about that -7 and this wider deal, you can find t-table points and make sure it fits the choices that you picked. All right, number 52 is similar to one we just did a minute ago, and 53 is going to be similar as well. So it looks like knowing -b over 2a is a big deal. You need to know that little formula to find the vertex of your parabolas. Now the one I was just talking about on 51, you can see the vertex. I don't need negative b over 2a to do the vertex here. It's in that completed square form. I can see the shifting rules. I know that vertex. If I know my shifting rules, I can do it without negative b over 2a. In this form, I do not know my vertex. I have to either complete the square or I have to use negative b over 2a. I'm promoting negative b over 2a is the easier way to do that. Anytime it's a parabola in standard form, this will help you find the vertex. And then the second part of the vertex is f of that, meaning plug that number back into the function. So here's your a, b, c value, just like with the quadratic formula. Negative of b makes negative 2 times a. That's negative 2 over negative 2 or positive 1. So that's the x shift of the graph. And then we plug 1 in for the x's, again with that weighting negative. That can be an issue, so make sure you're careful that negative weights. We're plugging 1 in for just the x values. So the negative is still outside of that. So 1 squared is 1, that makes it negative. 2 times 1 is 2 plus 2. Negative 1 and 2 is 3. Yeah, so the vertex is at 1, 3. So a sketch of that would look like it's moved over 1, up 3. And then because it's negative, it's downward. So it looks something like this.
That's all we have to do on that?
Yeah, since there's only one that is in the ballpark there, just graph A. Because graph B has the same, almost the same vertex, but it's upward. So yes, just match that to the right vertex and then it's down.
So if there's a negative in front of that x, it's down. If a positive,
So, that's true. Yeah, A. Okay, other questions on that? So you all make sure you know negative b over 2a, right? You got that? And your things to remember. I think that one helps a lot. Okay, we're going to use it again in number 53. So read number 53. Which time does it say that?
7 minutes.
And then we'll go to your iPhone maybe. Okay, so when you read number 53, you'll see that it's describing the situation where a rock is thrown off of a building. The building is 80 foot tall. How hard they threw the rock, the velocity is 136 feet per second. And then this has to do with the pull of gravity. Anyway, it kind of describes the equation, but bottom line is they gave you the equation. So we don't have to really derive our own equation. It's given to us and they just tell you what each one of these stands for. Here's what we need to know. We need to know that this is modeling a quadratic equation just like the one we just did earlier. It's x squared. Instead of using x, they use t though, but we're not bothered by that, right? Any variable's good. But so T is just more descriptive because they're talking about a real life situation with the rock being thrown, so T is time. Anyway, it's quadratic. So it is a parabola again. It's downward again, third time in a row, right? Another downward parabola because of the negative in front of the square term. So what they're asking you is determine the maximum height of the rock. So because it's a parabola, a downward parabola, the rock goes up, hits a high point, comes back down. The maximum height of that rock is really just saying find the vertex. Really, that's kind of code in all of your problem. If it says find maximum or minimum for a parabola, it's talking about its vertex. So anyway, negative b over 2a, again, right? We'll tell you how far out it is when it reaches its vertex, and then do the second part to see how high it is. So negative b is negative 136 over 2 times negative 16. You might have to help me out. Negative 136 over negative 32. Okay.
So you're doing the negative whatever, b over 2a.
4.25.
Oh, it doesn't come out even. Well, shoot. Okay, so 4.25. which is not a choice, so you know you're not done with this. And also because the question is how high does it get, this is the X part of the vertex that tells you how far out it is at its vertex. To see how high up it is, that's the Y value. So when you put that back in for T and do the second part of the vertex, the F of that, so negative 16 times 4.25 squared plus 136 times 4.25 plus 80. Punch that in your calculator, and that's your final answer. I'm counting on that being 369.
Wait, I got a fraction for 136/750.
Yeah. I was surprised too because I was thinking it'd come out even, but it didn't.
3413, is that what it's supposed to look
Yeah,
like?
that sounds
Because
right.
it won't let me take it to the decimal.
Yeah, okay, yeah, that should be right. Go ahead and plug it in your way, that's fine, for the T's and see if you get 369.
It tells you it's 4.25 when I did it for the division of the 136 and 32.
Yeah, mine does too, mine does the decimal, so I'm not sure what's going on with this. Might try that again.
Yeah,
get
it's still saying
369.
3413.
Oh, remind me to look at your calculator and see. 34 over 13 seeming a little small too.
We get 369, then what's next?
That is it, that is the answer, that's how high that rock goes, that's the second part of the vertex.
Oh, I'm looking at the wrong one.
Okay, 54, synthetic division. Yeah, I know. It's good news, right? We missed. Synthetic, I'll try to finish this one then before it dies. Synthetic division was that lovely little process where you could divide a binomial where x was to the first power. By using this neat little trick, we changed this to its opposite sign, so positive 2. Remember how we called that our k value? K is 2. It's always the opposite sign of how it's attached to x. So positive 2. Then we put all of our coefficients of our polynomial, making sure they don't skip a term. Notice x to the first is missing, so we have to put a 0. That's an important detail. It needs to be in descending order, x4, x3, x2, x1, and then constant. So leave a 0 if any places are skipped. Then pull down your first coefficient, 3, multiply and add your way across. Negative 10 and 8 is negative 2. 2 times negative 2 is negative 4. And the remainder is 7. The last number is the remainder. This represents our polynomial 1 degree down from where it started. So this starts at x to the third. So this is 3x cubed, 4x squared minus 2x. That's our constant. That's our remainder. Sometimes they want your remainder put over your divisor, and they do in this case. So we put our remainder over the divisor, x minus 2, and that's our answer to that division. It's just a shortcut to long division. I think I'll go ahead and have this one.
Okay.
Hit the red button.
Just hit this button to record.